In the spring of 1816, a farmer in northern Vermont named Chauncey Jerome recorded a single line in his personal journal that would outlast every official government report from that decade. June 10th, he wrote, "Snow, 6 inches deep. Corn dead. God has turned his face." That entry was not metaphor. It was measurement. 6 inches of snow fell across New England in the second week of June, killing crops that had already been planted, freezing rivers that had already thawed, and ending growing seasons that had barely begun. The temperature in parts of Connecticut dropped to below freezing on the morning of June 6th. In July, ice formed on ponds in Virginia. In August, frost killed what little had managed to grow in the fields of Pennsylvania. An entire year passed in which summer simply did not arrive across most of the northern hemisphere. The official historical explanation points to one event, the eruption of Mount Tambora in Indonesia in April of 1815. 1 volcano. 1 eruption. 1 year of cold. The narrative is clean. It fits in a textbook paragraph. But the farmers who lived through it wrote something more complicated. They wrote about a sky that had already been wrong for 3 years before Tambora ever erupted. They wrote about harvests failing in 1813 and 1814, about strange dry fogs that smelled of sulphur, about sunsets that turned colours no one had language for. They wrote about a pattern. And that pattern does not begin where the textbooks say it does. The first thing to understand is the scale of what happened in 1816, because the phrase "year without a summer" has been repeated so often that it has become a kind of historical shorthand, a curiosity, a footnote, an interesting weather anomaly. It was not a curiosity. It was a continental catastrophe that reshaped migration patterns, collapsed regional economies, and killed tens of thousands of people through famine, disease, and exposure. In New England alone, crop failures were total across at least 4 states. The price of oats rose from 12 cents a bushel to 92 cents in a single season. Families who had farmed the same land for 3 generations abandoned their properties and walked west, and the letters they left behind described not confusion, but terror. A farmer named Benjamin Harwood, living near the Canadian border in Vermont, kept a weather diary for the full year. His entries for June include frost every night through the month, ground frozen hard, nothing planted, nothing growing, wind from the north without ceasing. His entries for July record killing frosts on Independence Day. His entries for August describe ice on standing water. This was not a single cold snap. This was 12 consecutive months without a reliable growing season at latitudes that had supported agriculture for generations. The official explanation, volcanic aerosols from Tambora, blocking solar radiation, accounts for some of this. Sulfur dioxide ejected into the stratosphere does create a measurable cooling effect. Climate scientists have modelled this extensively. The models predict a global temperature drop of roughly 0.4 to 0.7 degrees Celsius following a major eruption. And that is where the first discrepancy appears, because the actual temperature anomalies recorded in 1816, particularly in the northeastern United States and Western Europe, were not 0.4 to 0.7 degrees. They were 3 to 6 degrees below normal, sustained over months, concentrated in specific regions in ways that a uniform stratospheric aerosol layer does not fully predict. The models work globally. They do not work locally, and it was the local devastation, the town-by-town, farm-by-farm destruction that the people who lived through it tried desperately to document. To see why the Tambora explanation, while partially correct, is incomplete by itself, you have to look at what was happening before April 1815. The eruption of Tambora on April 10th of that year was the largest volcanic event in recorded human history, a V7 eruption that ejected approximately 160 cubic kilometers of material into the atmosphere and killed an estimated 70,000 people in Indonesia. Directly. No one disputes its magnitude. No one disputes that it injected massive quantities of sulfur dioxide into the stratosphere. The question is whether it acted alone. Because the climate record shows that the northern hemisphere was already cooling before Tambora erupted. In 1809, an unidentified volcanic eruption, still unidentified to this day, deposited a significant sulfate signal in ice cores from both Greenland and Antarctica. Researchers have searched for the source volcano for decades. They have not found it. The eruption is real, the chemical evidence is embedded in polar ice, but the volcano itself has never been conclusively identified. Some candidates have been proposed. Researchers have pointed to a possible eruption in the southwestern Pacific. Others have suggested an event in Central America. None of these attributions has been confirmed. What is confirmed is that from 1809 onward, global temperatures were already suppressed. Harvests in parts of Europe were already diminished by 1812 and 1813. Napoleon's catastrophic retreat from Moscow in the winter of 1812 occurred during what was already an anomalously cold period across the continent. The so-called general winter that destroyed the Grande Arme was not a single freak season, it was part of a multi-year cooling trend that had been building since at least 1809 and possibly earlier. Tambora did not begin the pattern. Tambora intensified a pattern that was already in motion, and farmer diaries from New England, upstate New York, and the Ohio Valley confirm this. Crop yields were declining before 1815. Growing seasons were shortening. The cold did not arrive all at once in 1816. It accumulated, and the people closest to the land noticed it first. Here is what the textbook version of 1816 does not spend time on: the written record left by ordinary people. Not government reports, not scientific papers published decades later. The journals, letters, and almanac entries written by farmers, ministers, and village record keepers in real time as the disaster unfolded around them. These documents exist, hundreds of them. They sit in county historical societies, university archives, and private family collections across the northeastern United States and eastern Canada, and they describe something more textured, more disturbing, and more physically specific than any retrospective scientific analysis has fully incorporated. The Reverend Thomas Robbins of East Windsor, Connecticut, kept a diary that spans decades. His 1816 entries describe not only cold, but a persistent atmospheric haze that dimmed the sun for weeks at a time, a haze he compared to smoke, but noted carried no scent of fire. He recorded that the sky had a yellowish cast through much of the summer, that the sun appeared visibly reduced in size and brightness, and that the twilight colours were unlike anything in his experience. Similar observations appear in the diary of Adino Brackett in central Maine, who wrote in July 1816 that the air had a thickness to it, as of something suspended between the earth and the sun, of a nature I cannot determine. These are not scientists writing. These are careful observers recording what they saw with their own eyes, and what they recorded goes beyond simple cold. They recorded atmospheric phenomena, persistent haze, unusual optical effects, coloured snow, dry fog that suggest the composition of the atmosphere itself had been altered in ways that were visible from the ground. Sarah Snell Bryant of Cummington, Massachusetts, kept a diary that tracked weather conditions daily for years. Her 1816 entries show frost dates that violate every pattern established in her previous decade of records by margins that are not marginal. They are radical departures. Frost in every summer month. Snow in June. Ice in August. And between these events, brief periods of intense, almost violent heat sudden warmings that lasted 2 or 3 days before the cold returned. The oscillation itself is a data point. A uniform aerosol cooling would not produce rapid oscillation between extremes. Something more complex was operating on the regional climate, and the farmers' diaries captured a granularity that the large-scale models have not fully replicated. These were people whose livelihoods depended on reading the weather correctly. They were not prone to exaggeration. Their diaries were functional tools records kept for planning, not for posterity. And what they recorded in 1816 was a year that did not behave like any year they had ever measured, in ways that exceeded what a single volcanic eruption, even the largest in recorded history, would be expected to produce in isolation. Now place these two documented patterns side by side. The first pattern, a multi-year cooling trend beginning around 1809, linked to an unidentified eruption whose source remains unknown, compounding into the Tambora event of 1815 and producing cumulative atmospheric effects that exceeded what either event would have caused independently. The second pattern, ground-level atmospheric observations by hundreds of independent witnesses, describing not merely cold, but a visibly altered sky haze, dimming, colour shifts, oscillating extremes that suggest the aerosol loading of the stratosphere was more complex, more layered, or more persistent than the single eruption model predicts. These patterns converge on a single implication. The climate disruption of 1816 was not a simple cause and effect event. It was the product of compounding factors operating across at least 7 years, and quite possibly longer, in which the atmosphere accumulated enough particulate matter from multiple volcanic and possibly other sources to cross a threshold that produced regional effects far more severe than global averages suggest. The human consequence of this convergence was staggering and has been systematically underweighted in popular historical accounts. In Europe, the famine of 1816 and 1817 killed an estimated 200,000 people. In Ireland and Wales, typhus epidemics followed the famine and killed tens of thousands more. In Switzerland, the government declared a national emergency. In parts of Germany, bread riots broke out in cities that had been stable for decades. Crowds attacked bakeries and grain warehouses. Local governments printed emergency currency. And across the Atlantic, in the young American Republic, the failure of 1816 triggered one of the largest internal migrations in the nation's early history. Tens of thousands of families abandoned farms in New England and moved west into Ohio, Indiana, and Illinois. The demographic center of the United States shifted measurably in a single decade, driven not by opportunity, but by flight from agricultural collapse. The phrase 1800 and froze to death entered the folk vocabulary. It was not a joke. It was a compression of trauma into 5 words that families carried with them for generations. And the people who lived through it, who wrote about it, who testified to it in their own hand, produced a documentary record that the formal scientific and historical communities did not seriously engage with until the late 20th century. The gap between what was recorded and what was remembered is itself a pattern worth examining. The farmer diaries, minister journals, and local weather records from 1816 were not destroyed. They were not classified. They were not suppressed by any deliberate institutional act. What happened was arguably more effective than suppression. They were simply not consulted. For over a century, the dominant historical narrative of 1816 was constructed from institutional sources, government reports, diplomatic correspondence, published scientific commentary that operated at a scale too large to capture what was happening on individual farms and in individual communities. The farmer who recorded 6 inches of snow in June was not writing for an archive. He was writing for himself. And because he was writing for himself, no institution collected his testimony, indexed it, or incorporated it into the formal historical record. When climate historians finally began systematically gathering these personal accounts in the 1980s and 1990s, what they found was a record of far greater local severity than the institutional sources had conveyed. The institutional record said, global cooling, crop disruption, economic hardship. The personal record said, we watched our children go hungry. We ate roots, we boiled bark, we slaughtered animals we could not feed, and salted the meat with what little salt we could afford, and when the salt ran out, the meat rotted. The gap between those two descriptions is not a gap of accuracy. Both are accurate. The gap is a gap of perspective, And it matters because the perspective that was preserved, the institutional one, is the perspective that shaped how subsequent generations understood the event. The year without a summer became a scientific curiosity, an interesting data point in volcanology, a footnote in romantic literary history, because Mary Shelley wrote Frankenstein during the gloomy summer of 1816 in Geneva. That last detail has received more popular attention than the 200,000 European dead. The framing of the event in popular history has prioritized the atmospheric and the literary over the agricultural and the human. And the people who could have corrected that, framing the farmers, the ministers, the village clerks, were never asked. Their documents sat in attic trunks and county courthouses, uncatalogued, for 150 years. What survives today is enough to rewrite the standard narrative, and in some academic corners, that rewriting has quietly begun. The diary of Benjamin Harwood is preserved at the Vermont Historical Society. Sarah Snell Bryant's diary is held at Harvard's Horton Library. The Reverend Thomas Robbins's journals are archived at the Connecticut Historical Society. These are not obscure or contested sources. They are primary documents written in real time by literate observers with no agenda beyond recording what they saw. And what they saw, when read together, when placed in sequence, when mapped geographically, produces a portrait of 1816 that is more granular, more severe, and more human than the version that appears in any standard textbook. The ice core data from Greenland and Antarctica confirms the volcanic aerosol loading. The dendrochronological record tree ring analysis from sites across the Northern Hemisphere confirms the growing season suppression, showing some of the narrowest rings of the past 600 years in the 1810s. The instrumental temperature records that exist from European observatories confirm the cold, but the farmer diaries add something the ice cores and tree rings cannot provide. They add sequence. They add daily texture. They add the oscillation between extremes that a single annual data point cannot capture. And they add the human voice, the testimony of people who were not studying the climate but were being destroyed by it. A journal entry from an unnamed farmer in the Connecticut River Valley, preserved in a local historical society and dated August 1816, reads, "No corn, no hay, no prospect. I do not know what is to become of us this winter." That sentence contains more climate data than a dozen proxy measurements, because it captures not just the temperature, but the consequence. The fields that family had worked were still there. The soil had not changed. The latitude had not shifted. But for 1 year, or rather, for the culmination of several compounding years, the atmosphere between the earth and the sun carried enough particulate matter to make those fields functionally useless. The land was the same, the sky was different, and no one in a position of institutional authority recorded what that difference felt like on the ground. The eruption of Mount Tambora is real. Its climate effects are measurable and documented. Nothing in the farmer diaries contradicts the volcanic explanation. What the farmer diaries do is reveal the insufficiency of that explanation as a complete account. They show that the cold was more severe locally than global models predict. They show atmospheric phenomena, the haze, the dimming, the colour shifts, the oscillation that a single aerosol event does not fully explain. They show a multi-year pattern that began before Tambora and continued after it, suggesting compounding causes that the clean one volcano narrative does not accommodate. And they show a human catastrophe that the institutional historical record reduced to a curiosity. 200 years later, the same questions that the farmers asked in their own handwriting remain open. What was the unidentified eruption of 1809? And why has its source never been found? Why were the regional temperature anomalies of 1816 so much more severe than the global aerosol models predict? What other factors, solar minimum, oceanic circulation shifts, additional unrecorded eruptions, contributed to the compounding cold of the 1810s? And why did it take a century and a half for anyone to read the testimony of the people who experienced it firsthand? The documents are still there, the handwriting is still legible, the corn is still dead on the page, and the sky that killed it has never been fully explained.